Hello, and welcome to Tutoring for Engineering Excellence. My name is Royce, and in this video, we will discuss Wheatstone bridges and strain gauges. What is a Wheatstone bridge, and why are they important in engineering? To answer that, first we must talk about transducers. A transducer is a device which is exposed to one phenomenon and as a result produces another phenomenon. One example of a transducer that everyone is familiar with is a thermometer, which is exposed to heat and as a result produces a change in volume of the liquid in the thermometer. Another example is thermocouples, which are exposed to heat and produce a change in electrical potential. On the other hand, strain gauges experience mechanical strain and produce a change in electrical resistance. As you can probably imagine, there are many useful types of transducers in engineering, and many of these transducers rely on Wheatstone bridges. Wheatstone bridges are used widely in many disciplines of engineering, including mechanical, aerospace, chemical, industrial, civil, environmental, and more. Common applications of Wheatstone bridges include strain gauges, pressure sensors, torque sensors, thermistors, and more. In particular, the strain gauge is a very common device, and we are going to discuss strain gauges in detail. Now let's talk about Wheatstone bridges more. Wheatstone bridges are special circuits which are used to determine the resistance or change in resistance across an element, such as a strain gauge. We know that the resistance of an element depends on its geometry. When a strain gauge experiences strain, its cross-sectional area and length change, resulting in a change in the strain gauge's resistance. A Wheatstone bridge can be used to measure this change in resistance, and then the strain experienced by the strain gauge can be calculated if certain properties of the strain gauge are known. The strain in a strain gauge corresponds to the strain of the surface it is attached to, so this allows us to test materials and parts and collect useful data about their strain. Strain gauges are thin and small, wafer-like devices, and they are attached to the surface of a material, usually with some sort of adhesive, such as glue. A Wheatstone bridge is as follows. It is a voltage source and two pairs of resistors in parallel. The voltage from the top node to the bottom node is equal to the source voltage for both branches, but the voltage at the node in the middle of each branch, labeled here as L and R, may change depending on the values of the four resistors. The voltage across these nodes may be measured, and then if the values of some of the resistors are known, we may calculate the resistance in the unknown resistors. We will call the voltage between the right node and the left node Vg. There are several configurations of Wheatstone bridges, and each one may be useful in different applications. There is a quarter bridge configuration, a half bridge configuration, and a full bridge configuration. In a quarter bridge, the resistor in the position I've labeled as number 1 is replaced with an element of unknown resistance, and the other resistors all have known resistance. In a half bridge, both of the resistors in one of the parallel branches, for example number 1 and number 2, are replaced with elements of unknown resistance. And for a full bridge, all four of the resistors are replaced with the elements of unknown resistance. If you want to measure strain in particular, then your strain gauges will be your elements of unknown resistance. In this case, the initial resistance of the strain gauge is usually known, but as a strain gauge experiences strain, its resistance changes and becomes unknown. Now, the configuration of your Wheatstone bridge will depend on your application. Half bridges provide twice the sensitivity of quarter bridges and may also be physically arranged perpendicular to each other along the principal strain axes to measure torsional strain. Full bridges, on the other hand, provide 4 times as much sensitivity as quarter bridges. And if you're wondering what sensitivity is in particular, sensitivity is the smallest quantity that can be measured by a device. So greater sensitivity allows us to measure smaller quantities, and this is helpful if you're measuring very small quantities, for example, millivolts or quantities even smaller than that. The equations for the change in the voltage across the middle nodes, delta VG, for each configuration is as follows. For a quarter bridge, delta VG equals Vs, the source voltage, times delta RG, where RG is the resistance of the strain gauge, or the resistance of your unknown element, all over 4RG. So resistance is not a value we can measure directly, but voltage is. So we can measure the change in voltage and we can relate that to the change in resistance using this equation. Now, that is for a quarter bridge. Now for a half bridge, delta VG equals Vs R1 R2 all over R1 plus R2 squared, in parentheses, delta RG over RG 1 minus delta RG2 all over RG2. Now, for a half bridge, there are 2 resistors of unknown resistance. So RG1 represents your first resistor of unknown resistance, which should be in the 1 position as shown before, and RG2 being another element of unknown resistance in the number 2 position. Now for a full bridge, delta VG equals Vs delta RG over RG. So there we have our equations for delta VG in the 3 different configurations of Wheatstone bridges. So now we know delta VG, and these 3 equations can be applied for any element of unknown resistance, not just strain gauges. So these are the 3 equations that are most important that you will want to keep in mind. Now, but if you are using strain gauges, the next step is to calculate strain using delta VG. And that is pretty simple. The equation relating strain to delta VG, let's move on to another page. The equation relating strain to delta VG is strain equals 4 delta VG all over Vs G sub F. So this is the strain in a strain gauge in a Wheatstone bridge. So you see this variable GF, and GF is it's a property called the gauge factor of the strain gauge. And this type of information is usually provided by the manufacturer of the strain gauge. So now we can calculate the strain on materials and parts as long as we have a strain gauge and a Wheatstone bridge. Now that wraps up this discussion of Wheatstone bridges and strain gauges. We discussed what Wheatstone bridges do and discussed the purpose and use of strain gauges, which are an application of Wheatstone bridges. Thanks for watching.